A cheap DIY trick that could slash your heating and cooling bills to near zero. But some states restrict or make it hard to use. Why? Energy bills are rising and the numbers are hard to ignore. Since 2021, the average US household has seen electricity costs climb by 15%. In some pockets of the country, the spike is even sharper, fueled by natural gas price jumps and relentless summer heat. For families in the Midwest and Northeast, the pain isn't just in the wallet, it's in the ground beneath their homes. EPA radon hazard maps show clusters of high risk in states like Illinois, Pennsylvania, and Ohio, where radioactive gas seeps up from the soil, invisible and odorless. Meanwhile, the Southeast faces a different threat. USDA data reveals average summer humidity topping 60% from Georgia to Florida, turning basements and crawl spaces into breeding grounds for mold and condensation, especially when air is drawn through cool underground pipes. The promise of a simple fix: buried pipes that use the Earth's steady 50 to 55 degree temperature to pre-cool or pre-warm air sounds almost magical. The method is straightforward. Dig a trench 6 to 10 feet deep, lay sealed PVC or HDPE pipe, slope it for drainage, add gravel, and cap it with a filtered intake. A small fan draws outdoor air through the system, delivering comfort at a fraction of the cost of central AC or heating. Material costs can dip as low as $5 per foot, and the fan's power draw is barely a blip on the meter. But in counties where radon and humidity risks overlap with soaring bills, the story takes a turn. Inspectors have started demanding permits, radon testing, and proof of proper drainage. Past failures, radon pulled straight into homes, mold from pooled water, standing condensation inside pipes have triggered new scrutiny. Now, a patchwork of restrictions and warnings leaves homeowners caught between the lure of $5 per foot miracle and the threat of a hidden hazard. The question lingers: is the solution a breakthrough or a risk waiting to surface? Rebecca Sneed still remembers the day her phone rang with a complaint that sounded almost impossible. The caller's family, living in central Illinois, had installed an underground air pipe system hoping to cut their heating bills. Instead, they found themselves facing a radon spike. Indoor measurements hit 12 picocuries per liter, 3 times the EPA's action level. Within months, headaches and health worries pushed the family to file a lawsuit. The installer settled in 1998, agreeing to rip out every inch of pipe and pay for radon remediation. That case made headlines, and it didn't stop there. The Illinois Department of Public Health issued a statewide warning about earth tube ventilation in high radon counties, and inspectors began flagging any unsealed underground ductwork as a red flag for permit review. Another disaster unfolded in New Mexico, where a custom home built in 1978 used a buried earth tube for passive cooling. The pipe ran too flat, less than 0.5% slope, so water pooled after every rain. Within 3 years, black mold coated the inside of the tube. The homeowner sued, and the contractor had to pay for removal, mold cleanup, and a complete redesign. The court opinion called out the missing slope and lack of drainage as the main culprits. Stories like these aren't just cautionary tales. They shape the rules that inspectors enforce today. The 2021 International Residential Code, Section M2007, requires mechanical permits and proof of safe design for any underground air system. Many states now demand a minimum 2% slope for drainage, sealed pipe joints, and a radon barrier in high-risk areas. Florida's building code goes further, requiring a waterproofing plan and humidity control for earth tubes in the Southeast's muggy climate. Rebecca Sneed, now a building code consultant, says the message is clear. A $5 hack cannot cut corners on safety. Inspectors look for proper slope, sealed pipes, drainage gravel, and a filtered intake. They want to see radon test result before sign-off. The rules aren't about blocking innovation, they're about stopping a cheap fix from turning into a hidden health hazard. Across the country, the paperwork may differ, but the lesson from every failure is the same. Ignore codes, and the earth tube that promises savings could end up costing far more. Thomas Lee's diagram looks almost too simple. A single line for the pipe, a few arrows for airflow, and a shaded trench labeled gravel bed. Yet that's the entire core of the hack. The materials list reads like a weekend project, not a major renovation. Start with a 100 to 200 foot length of 4-inch HDPE pipe, durable, smooth-walled, and easy to snake through a yard. That's the main expense, but in many regions, reclaimed or surplus pipe brings the cost as low as $5 per foot, sometimes less. Next comes the gravel, a 12-inch layer of washed stone laid in the bottom of a 6 to 10 foot deep trench. The gravel isn't just for stability, it's the drainage bed that keeps water from pooling around the pipe, fighting off the mold and condensation problems that doomed earlier designs. At the intake, a simple MERV 8 filter snaps into place, blocking dust and spores before they can travel the length of the tube. The AIR is pulled through by a low power fan. Lee specs a 15-watt centrifugal model, barely more than a nightlight, run all year. It draws about $2 worth of electricity, a tiny fraction of what central AC or heating would use. Lee's diagram calls for a continuous downward slope, at least 1%, so any condensation or rainwater drains out naturally. The pipe joints are sealed tight, not just to keep out groundwater, but to prevent radon-laden soil gas from sneaking in. The filtered intake sits well above ground, shielded from debris and critters, while the outlet connects to a vent or supply register inside the home. No fancy electronics, no moving parts except the fan, and no special tools beyond a shovel and a level. The total material cost? In Lee's own Colorado build, the pipe was $42, gravel $30, the fan $25, and the filter $12. That's less than $110 for a system that can run for years with almost no maintenance. The real draw is the promise. Near 0 meter readings for heating or cooling, especially in regions where ground temperature sits at that magic 50 to 55 degree sweet spot. The system is so stripped down, so accessible that it's easy to see why the $5 hack label stuck. But as Lee and others warn, the devil is in the details. Get the slope, sealing or drainage wrong, and the savings can vanish overnight. Utility data from Colorado and Wyoming tells a striking story. In Fort Collins, a family tracked their bills for a year after installing a 150-foot earth tube system. Their HVAC electricity use dropped by 58% during the cooling season, cutting over $150 a year from their bill. A Wyoming rancher using a similar setup logged a 71% drop in furnace electricity use through the winter. The secret wasn't magic. It was a $110 investment, reclaimed HDPE pipe, a gravel trench, a radon barrier, a 15-watt fan, and a basic air filter. With the ground holding steady at 50 to 55 degrees, the system pre-warmed icy winter air and pre-cooled stifling summer breezes, letting the main heater and AC sit idle for weeks at a time. But these savings only stick when the details are right. Inspectors and code officials have seen too many shortcuts turn a bargain into a liability. In high radon zones, like much of the Midwest and Northeast, permits now require a sealed pipe, a continuous radon barrier, and post-installation testing before the system can be used. In the Southeast, where humidity is relentless, building codes demand a drainage plan and proof that water won't pool inside the tube. New York City's mechanical code goes further, requiring a performance calculation showing at least 10% energy reduction before issuing a permit, plus a radon blocking membrane for any underground air duct. For anyone tempted by the promise of near zero heating and cooling bills, the checklist is non-negotiable. First, check your local code office and radon map. Then, use only rigid, sealed PVC or HDPE pipe, laid with at least a 1 to 2% slope for drainage. Add a gravel bed beneath and around the pipe, install a MERV 8 filter at the intake, and wrap the trench with a polyethylene radon barrier if you're in a risk zone. Always get a permit if your county requires it, and have the system inspected before covering it up. Skipping any step isn't just risky, it could void your home insurance or trigger a stop work order. The bottom line, the $5 hack can deliver real savings, but only when it's built to code and designed for your region's hazards. Right now, energy bills keep rising, and DIY hacks draw more eyes, so scrutiny only grows. Whether this ultra-cheap fix becomes mainstream depends on how well safety keeps pace with savings. In a world chasing lower bills, the real challenge is making simple solutions truly safe. What's your take?